Hello everyone, Mr. Chantry, your neighborhood planetarium director here, with the special Mars Perseverance Landing Edition of Evening Sky Excursions, where I share information about the February 18th attempt to land a new rover on the Martian surface. The Mars2020 Perseverance Rover launched back on July 30th, 2020, and will arrive on the surface of Mars February 18th, 2021. It will join two currently operational Mars surface missions, InSight, an instrument that landed in December of 2018, and the Mars Science Lab, or Curiosity rover as it's known, which landed in August of 2012. In addition to these surface missions, there are multiple satellites in orbit around our red-colored neighbor. There will be a live stream of the event starting at 2:15 p.m. on the 18th on NASA's YouTube page at www.youtube.com/NASA, or go to mars.nasa.gov/Mars2020 for links and all the information for this mission. Just getting to Mars from Earth is a challenging task because as Earth and Mars go around the Sun, they're not traveling at the same relative speeds. As they orbit the Sun, the two planets are only at their closest to each other about every 26 months. Mars and Earth reached their closest distance, what astronomers call Mars opposition, on October 13th of 2020. The rover launched towards Mars back in July of 2020, not October. If we would have launched this rover straight at Mars while our planets were at their closest point, it would have been the shortest distance from Earth to Mars. But when the rover would have arrived at where Mars was months ago, Mars wouldn't be there anymore. To be efficient, we had to launch the rover in July and aim to where Mars is going to be on the 18th of this month. This is much like throwing a ball to someone while they're running, or more accurately, like driving a golf ball from the back of a moving truck in New York and getting a hole-in-one in a hole that's on the back of another moving truck in Los Angeles.
It looks like I'm a wreck. It's in the hole!
If getting to Mars is challenging, landing something the size of a small SUV on the surface pushes the frontier of human engineering and problem solving. One of the biggest challenges is the Martian atmosphere. The atmosphere, or air on Mars, is about 100 times thinner than Earth's atmosphere. It is so thin that even using technology like giant parachutes isn't enough to slow down a craft to a safe landing speed. But the atmosphere is thick enough that you can't just pretend like it's not there, like you would do to land on the moon. There have been different methods used by engineers to get landers through the Martian atmosphere and safely to the surface, a process they call EDL, which stands for Entry, Descent, and Landing. On the 18th, the Perseverance rover will use almost the exact same method that the Curiosity rover successfully performed back in 2012. As the spacecraft approaches Mars, it will get rid of its cruise stage, which is like a backpack used to steer, navigate, and communicate during its 6-month trip in space. It will enter the thin Martian atmosphere at about 12,000 miles per hour. That's almost 10 times the speed of a bullet. At this speed, even the thin atmosphere rubs on the spacecraft so much that it causes a huge amount of heat. Take a few seconds and rub your hands together really fast. Go ahead. I'll wait. You can feel the heat created from the friction of your hands. Now imagine rubbing your hands together at 12,000 miles per hour for a few minutes. That would cause a lot of heat. The landing capsule has a heat shield on the front of it that will heat up to over 2,000 degrees Fahrenheit and protect the rover inside. All of that friction will slow the descent of the capsule down to about 900 miles per hour. At this point, the craft will deploy its gigantic supersonic parachute. Since the air on Mars is so thin, the parachute will only slow the capsule's descent down to about 200 miles per hour. While the parachute is open, the bottom heat shield of the capsule will drop off, and cameras, radars, and computers on the rover will start figuring out how high it is, how fast it's going, and where exactly it wants to land. Since 200 miles per hour is still way too fast to safely land, the rover will cut away from the parachute and use what is basically a rocket backpack to slow down the rest of the way. But wait, there's more! The rover can't land with the rocket backpack on because the rocket engines shooting down could kick up too much dust and cause all kinds of problems. So it performs what is called the sky crane maneuver. The rocket pack lowers the rover down to the ground for the final 21 feet on 4 cables. Once the rover touches the ground, it cuts its cables. The backpack flies away and crashes in the distance so it doesn't get in the way of the rover. This extremely complex process of slowing down from 12,000 miles per hour to safely touching down on the surface takes about 7 minutes. Engineers at NASA have dubbed this the 7 minutes of terror, because all of these complex steps have to happen perfectly, and there's nothing that they can do if something goes wrong. On the 18th, Mars will be about 130 million miles from Earth. The radio transmissions between Earth and the rover, which are just forms of light, take more than 11 minutes to travel that distance one way. Even if they saw that something was going wrong, it would already be 11 minutes later on Mars, and the whole EDL process only takes 7 minutes, so there's nothing that they could do to fix it. This is what makes these 7 minutes terrifying to the many engineers who have spent years working on this project. The landing will be recorded through various cameras and sensors on the spacecraft, but might not be viewable immediately. These videos will be stored and transmitted back to Earth in the days after the landing, and will make for some really cool videos. Once on the ground, the goals of the Perseverance mission are to determine whether life ever existed on Mars, to characterize the climate on Mars to see if conditions could have been habitable for life in the past, characterize the geology of Mars, and prepare for human exploration of Mars. The landing site for Perseverance, called Jezero Crater, is on the edge of a flat area called Assidius Planitia. Current evidence, including satellite images like this, strongly suggest that this area was a river delta with flowing water a few billion years ago. Here on Earth, we know that ancient river deltas, which are landforms created by rivers depositing sediment as they enter larger bodies of water, are excellent places to find fossils and other evidence of past life. Scientists believe that if life was present on Mars in the past, this would be one of the best places to find evidence of that life. Landing near the edge of this crater is only possible because of the new terrain relative navigation system that will allow Perseverance to recognize the rough terrain and avoid obstacles during landing. As the craft is landing, it will use stored maps of the area, onboard cameras, and artificial intelligence to decide on the safest place to land that best meets the mission goals. To analyze the geology of the rocks in Jezero Crater, Perseverance will use multiple tools. It has many cameras that look at rocks in a variety of magnifications and in different kinds of light to understand what chemicals the rocks are made of. It also has a laser that will blast small portions of rocks, and a camera that uses the light from that blast to better understand what the rock is made of. The rover is the first mission to the Red Planet to have a ground-penetrating radar to help scientists understand what is just below the surface of the rover on Mars. Another first for this mission is a microphone on one of the cameras that will not only listen to various instruments and movements of the rover, but will also record the first sounds on Mars. There is also a drill that can drill into the rocks, take samples, and store them in tubes. These samples of rocks will eventually be dropped, then picked up by a future mission that will return them to Earth. Although the instruments on the Perseverance rover are very advanced, scientists could learn so much more if they had the rocks in their labs here on Earth to run more experiments. It will still be a number of years before these rocks make it back to Earth, but it will be very exciting when they do. Along with the instruments that will help to understand the geology of Mars and help scientists determine if life might have existed on the planet, the rover also has Moxie.
What's Moxie? Tell him, Marty.
Moxie is a technology demonstration that may help humans when they visit our planetary neighbor in the future. A technology demonstration means the experiment is just testing the engineering capabilities and limits of a tool, and not necessarily trying to measure something new about Mars's physical characteristics. Moxie will be testing a way to take carbon dioxide, or CO2, that makes up most of the thin Martian atmosphere, and turn it into regular oxygen, or O2, that humans can breathe. This is basically what plants do here on Earth. They take in CO2 and exhale or put out O2. This could be a big benefit to future human missions to Mars, because along with being too thin for humans to breathe, the Martian atmosphere does not have enough oxygen to support humans. This experiment could lead to a machine that can turn the toxic air into a resource astronauts could breathe, and even turn into rocket fuel. This means that future astronauts may not have to bring all their air and fuel with them from Earth. They may be able to make some of it once they get to Mars. Perseverance doesn't just have Moxie, it also has Ingenuity. Ingenuity is another technology demonstration on the mission. This 4-pound helicopter will attempt the first powered flight on another planet. The ability to fly around over the surface of Mars could greatly decrease the time it takes for missions to move from one interesting site to another. But there are many challenges to overcome. The first challenge, similar to just landing on Mars, is the thin atmosphere. Since the Martian atmosphere is 100 times thinner than here on Earth, there are 100 times less air molecules for the rotor blades to push on to lift the drone off the surface. Ingenuity's 2 rotors will spin in opposite directions at more than 2,400 rotations per minute to generate the lift necessary to fly. Also similar to landing on the surface, Ingenuity's onboard computer will need to control the craft during flight because of the more than 11-minute signal travel time from Earth to Mars. If you still want more Mars after watching the landing and going through all the information on the mission page on the 18th, why not take a step outside after sunset, around 6:30, and catch a glimpse of Mars in the sky? If it is clear on the evening of the 18th, Mars will be especially easy to find, as it will be positioned just above the first quarter moon. Find the moon and look for the bright reddish colored spot above it. That is Mars, more than 130 million miles away. As you gaze up at our planetary neighbor, think about the questions that this mission hopes to get closer to answering, like, is the Earth the only place with life? Or is it something that happens other places too? On February 18th, remember to tune in, look up, and as always, be excellent to each other.